In this lab, we are going to see how to configure routings so that traffic of different VPCs should get inspected with firewall security policy. And even this firewall VPC should be the exit VPC for all internet bound traffic, means only one Palo Alto firewall in firewall VPC, because total there are three different VPCs: VPC1, VPC2 and firewall VPC. Palo Alto firewall is in this firewall VPC. VPC1 and 2, they do not have any Palo Alto firewall, but objective is to inspect their traffic with firewall security policy. And not only the internet bound traffic, even the traffic that is not meant for like internet, meant for like VPC2, means we also want to control inter VPC traffic, inter VPC communication, right? Means we want routing to happen this way from EC2, from this EC2, and then packet will hit to the VPC routing table. VPC1 routing table has one local route and another route any network, and then VPC1 transit gateway, this one. So there is one transit gateway, and this is basically attachment. Attachment name is VPC1 transit gateway. So first step, EC2 to VPC routing table. VPC routing table has route no matter what the destination is, either VPC2 network address or internet bound traffic. What should be the target? VPC1 transit gateway, right? So what will happen then? Step number 1, packet from EC2 to VPC1 routing table here, and then using this attachment will hit the packet transit gateway. Now transit gateway has 3 routing tables. One routing table for this VPC1, and this is transit gateway routing table. Transit gateway routing table, right? So VPC1 transit gateway routing table has like route 000, any network address, any subnet mask, and with attachment this, and this attachment goes to private subnet of firewall VPC. So what will happen? First here like the local VPC routing table, second transit gateway routing table, but transit gateway routing table for VPC1, right? So next step, third, private subnet routing table. Now third, private subnet routing table, this one. And remember in the previous lab exercise what we did, we created default route with the target Palo Alto firewall. So the third, after third lookup, packet will hit Palo Alto firewall internal interface, right? Clear so far? Let me repeat one more time. So first step, EC2 to VPC1 routing table. Step number 2, with this default route, like packet is forwarded to transit gateway. Transit gateway has 3 different routing table. One routing table, transit gateway routing table, is for VPC1, and this route table has default route with the target this attachment. So this way packet is forwarded to private subnet routing table. This private subnet routing table has a default route we just created in like previous lab exercise, and target Palo Alto firewall, right? So Palo Alto firewall will check the security rule, destination IP, and now if the destination address is 10.2.1.15, then what will happen? Palo Alto firewall will check the routing table. Do I have route for 10.2.1.15? And if it finds a route in the routing table, then packet will be routed to egress interface, right? Means we will have to create a static route where in Palo Alto firewall virtual routing table. Means if the traffic is cleared and it's not internet bound traffic, so traffic will take the same path. again the return path would be like here. So first, like this Palo Alto firewall should have route that in order to reach 10.1 or 10.2, the exit interface should be what? Ethernet 1/1 interface, this interface, right? So we'll hit the private subnet routing table. Now this private subnet route table should have route for both 10.2 and 10.1, and where pointing towards the transit gateway means this attachment, and already attachment is associated, right? So the packet will be then forwarded to transit gateway. Now transit gateway should have a route table again for this attachment, and in this routing table route for both the VPCs. So now transit gateway knows, like if I have to route packet for 10.1, then I will go this way, and for this way. So we will have to complete routing, right? Let me quickly take you to AWS console and prepare infrastructure. I mean, like creating a VPC1 and note down the CIDR block here, and then VPC2, one subnet here and one subnet here, and no internet gateway. Internet gateway is not required. Without internet gateway, even this EC2 machine should have internet access, right? That's why via Palo Alto firewall. Even this EC2 machine, if like wants to communicate with EC2 of another VPC, then the path would be like this. So first thing first, and first I'm going to create two VPCs and note down the address CIDR block and 10.1.0, 10.2.0, and the subnet address 10.1.1.0, 10.2.1.0. And for testing purpose, we will spin up one EC2 in this subnet, VPC1 subnet, and another in VPC2 subnet. Right, good so far. And then this route table, yes, routing need to be done manually, transit gateway attachment, and here. So once like is done attachment and other stuff, then we'll take care of routing. So I'm going to what you call it, create VPC first and then subnet routing table. So on this page VPC, and so already there is one firewall VPC, and Palo Alto firewall is even running. So we have just finished like the previous lab session. So we spinned up Palo Alto firewall, the same topology I'm using, right? So you'll have to refer my previous session. In fact, create VPC, and I will name it VPC 01 10.1.0.0/16. Done. One VPC created. Create another VPC. It's very straightforward. You understand like how to create VPCs. So I'm not going to waste time here. 16. Then two subnets. Right. So here total 3 subnets. So I'm going to create subnet in VPC1. So subnet, let me, or VPC1 subnet, alright, 1A, and here 10.1.1.0/24, and only one subnet, and then subnet 2 in VPC2. So this time VPC2 subnet, and here I take the same 10 dot, and was subnet address 10.2.1.0. all right, 10.2.1.0/24. create routing table by default created, and I'm going to use the same route table, no problem. So even we can use just give the name here. So VPC1 created here, a routing table automatically created. So just name it VPC1 routing table, and the VPC2 routing table also created. Where is VPC2 routing table? This one. So better just to give a name here, VPC2 routing table, right? And if we check the routing table and association, since by default routing table is created, so we don't have to explicitly associate subnets. So even in case if you want, then yes, you can do that. Even if you don't do, no problem, because it's a default routing table, so there is implicit association, right? And routing table definitely would have only one route, local route. Next, what I'm going to do, because I will spin up EC2 later on. So next I'm going to spin up, not spin up, create a transit gateway, right? Transit gateway takes time. And why transit gateway? Because different TGW, different VPCs do not communicate, right? So for that, we are using transit gateway here, and the solution is what? And the solution is peering. And important point here, uncheck these two options. Why? Because we want full control. We want to associate like attachment with the transit gateway routing table manually. We also want to create a static route, no route propagation. So that is why, right? Because we can customize like routing and association as per the requirement. So turn off, and yes, done. So gateway, yes, it is state is pending. So far we have created VPC1, subnet 1, VPC2, subnet 2, routing table by default created. Just we rename, and we are using the default routing table, and by default one route is created. So this route table one route, and VPC2 routing table one route, right? Route with the red color need to be created manually. But before that, we want to create attachment. Attachment is what? A logical connection between VPC and transit gateway. So two attachment here, and basically three attachment, because there are three sub VPCs, right? So three attachment. I'll name this attachment as VPC1 TG, VPC2 TG, and the third one is firewall VPC2 transit gateway. So three attachments. So once transit gateway is available, then we'll create three different transit gateway. And since manual automatic propagation association, both options turned off, disable, means like we would have to do all the configuration manually. I mean, like creating transit gateway routing table, uh, association even, yes, right? So refresh, hopefully should be available, yes. So go to transit gateway section one more time and create attachment, three attachment, right? Create attachment, I will name it VPC1 TG. So first attachment VPC1 to TGW, a transit gateway. Select the transit gateway, attachment type VPC, and select the VPC, VPC1. Create it, and then create another, this time VPC2 to transit gateway. Select the transit gateway, VPC, VPC ID, this time VPC2, there's only one subnet. Create transit gateway attachment. But firewall VPC has three subnets, right? So make sure that attachment is created with subnet, private subnet, right? Private subnet. So the third attachment, and this is firewall VPC2 to transit gateway, and select the firewall VPC from the list, and here select private subnet. Make sure that private subnet is selected here and create. So 3 attachment created, right? So let me, so still these two are in pending, no problem. So in the meantime, configure like routing table of both VPC1 and VPC2. And what we want here, we want to put a route, default route pointing to the gateway. Means any network address, any subnet mask, any network address, any subnet mask next to the target of this VPC should be transit gateway going this way, right? And further, transit gateway will take the decision. It's a hop by hop routing, right? So even traffic destined for VPC2 or traffic destined to any internet bound IP address, they all will hit the transit gateway routing table first. And that is why we are not going to create a specific route here or default route. Default route will work here, no problem whatsoever. Because it's something like hub and spoke topology, right? And you understand, like in case of hub and spoke topology, these are stub networks. So yes, we can do routing with the default route only. And that's what we have been doing here. And the same VPC2 routing table, right? So at least complete like configuration of this VPC and this VPC, right? So only configuration that is pending is what? Creating default route only. And then later on we'll spin up like EC2 in both VPCs just for the testing purpose. Then once like done, then I will move to the transit gateway routing table. So creating 3 separate routing table, doing routing in both the direction, and then we will move to Palo Alto firewall. We'll check the routing table here, private subnet routing table even. So a lot of routing. Okay, so I believe attachment, yes, they all are available. Routing table, VPC1 route table, routes. So what I'm going to do here, I'm going to create default route pointing to transit gateway. Select the transit gateway, done. VPC1 routing table, done. Same with VPC2 routing table. Straightforward, right? So routes and click here, edit, add default route, transit gateway, done. Okay, what about transit gateway routing table? Transit gateway routing table. So transit gateway is created, 2 attachment, 3 attachment rather, 3 attachments created. What about transit gateway routing table? No transit gateway routing table found. Why? Because we disabled propagation association at the time of creating transit gateway. So what I'm planning to do now, I'm planning to create 3 routing table on this transit gateway. One routing table dedicated for VPC1, another routing table dedicated for VPC2, and the third routing table for firewall VPC. Understood? 3 routing tables. So step by step, just I'm going to show you the configuration because it's a bit complex in fact, right? So if I do a configuration in single go, so you will get confused. I don't want to confuse you. So that is why I'm just moving step by step, right? No rush, no hurry, just step by step. So this portion done, this portion done. Next device is transit gateway. First, I'm going to create 3 separate routing table and then I'll show you routing. So create transit gateway routing table. So transit gateway routing table. I will name it TG routing table for VPC1, right? Select transit gateway and create. So one routing table is just routing table. I just created a routing table, right? And can I copy the name just to save the time? Copy this, create another routing table, and this time for VPC2. No route, no association, only routing table, and the third routing table for firewall VPC. So this is for firewall VPC. Alright, 3 routing tables created successfully for transit gateway. One is available, rest 2 pending, will be available very soon. What next now? Routing table created, but it's blank routing table. As so there is no route here. So next is what? Associating this attachment with the routing table. Means if any traffic coming from VPC1, maybe from this EC2, using this transit gateway, so in which routing table routing should be done? I mean, like to which in routing table this transit gateway interface is like terminating. It's something like putting interface in VR of virtual routing and forwarding. Means this VPC1 transit gateway attachment, this attachment need to be associated with a routing table. Which routing table? VPC1 routing table, right? VPC1 routing table. So what will happen if any packet or traffic coming from VPC1 using this attachment will be checked in VPC1 routing table. So attachment means this only, right? Attachment means what? Attachment means like if transit gateway has 3 separate routing tables, so which routing table should be used for routing purpose? So that's what association is. So basically this attachment will go to this routing table, another attachment, firewall, and third attachment here. So that's what association is. Association is not routing. Association is like putting transit gateway attachment with respective routing table. So VPC1 and first let me show you the association. Association, no association because we disable automatic association. Create and which one? TG1 attachment. Transit gateway attachment between VPC1 and TG. Create association. Select VPC2 association. Which one? 2 transit gateway to VPC2 and then select the third one, firewall VPC association. Create and select firewall VPC. Done. What about routing now? Routing, the next one, really important in fact, because uh, what will happen? I mean, like if traffic is destined to maybe 10.2. So from here, like routed to transit gateway. Transit gateway has a separate routing table. Attachment is associated here. Now this routing table should have route for 10.2, right? Or even I can do routing this way 000, right? So 000 means any, and then target should be this. Same for VPC2 and one direction. Just do routing in one direction first, like this way. Just uh, uh, ensure that packet reaches firewall, Palo Alto firewall, like I mean like this way, and then we will take like we'll configure routing for reverse traffic in reverse direction. So one way first, right? So one way means like VPC1 routing table to transit gateway routing table, and here is the transit gateway routing table for VPC1 association. Already done. Then routing, no routes, edit. So here create a static routing table, and for what? If I say any network address, any subnet mask, and then firewall attachment, create a static route. Same if so, now this has a route now, and same if I configure in transit gateway routing table for VPC2 route, create 000 active root, no black hole, firewall VPC, transit gateway, create. So what we have configured so far, like from here for routing, transit gateway routing table for VPC1 is checked, and this routing table has a default route which was created, and the target is this one. So target is firewall VPC TG. So this will be like routed via like another attachment, right? And this attachment is terminated where private subnet, means now packet reaches private subnet routing table. Private subnet routing table, if you remember, so already it has a route, default route pointing to Palo Alto firewall. So we don't have to do anything here. Let me quickly show you private subnet routing table because we did routing in previous lab exercise. So if I show you the managed internal or private subnet routing table, so click subnets, private subnet route table. So here, even if I just to show you, let me click edit. So here it has a route. Private subnet routing table has a route, any network address and ENI of Palo Alto firewall. So we don't have to do any routing on private subnet routing table. Done. So packet reaches from here, means like VPC1 routing table to transit gateway routing table, checked here in the transit gateway routing table, then forwarded to private subnet routing table. It has default route, then forwarded to Palo Alto firewall. Palo Alto firewall will do the inspection, and what I'm going to do, and we are taking just like only one direction here, right? And then later on we'll configure reverse routing, reverse path I mean. So I'm back to this Palo Alto firewall, no policy here. So for policy, what I'm going to do, a very simple policy I'm going to create. Source any, let's say I say permit, because you understand like how to control traffic with Palo Alto firewall security policy. So just like I don't want to be restricted to any destination any, application any, service any, action log assertion start and okay. So my firewall security policy is not restricting anything, but you understand like you can control traffic with security policy here, and that's the objective. The lab objective is what? To control traffic with firewall security policy. So how to create policy in Palo Alto firewall, you know that very well. So I don't have to tease that. So you can create a proper security rule to control traffic, and for internet bound traffic, even like source NAT is required here. So what I'm going to do, I'm going to create a source NAT policy also for internet bound traffic, and VPC1 to VPC2 not required. So source NAT policy, original packet, source address, zone inside, destination, outside, source address. If you want to type, then you can type, otherwise you can take any, no problem. Translate packet, dynamic IP and port, and external interface, that is Ethernet 1/2. DHCP assigned IP none. Routing, sorry, policy is done, right? But the big question here, now packet coming from 10.1.1.15 reach to the Palo Alto firewall. Palo Alto firewall check the security policy. Now let us assume destination is 10.2.1115 destination, right? Because for internet bound traffic is done, but like routed to the internet. But what if the source is 10.1.1.15 and destination is 10.2.1.15? So this packet reaches Palo Alto firewall, hope by hope routing, of course, hope by hope routing. Palo Alto firewall, check security policy, allow it right here. Let's say uh, now this packet has to take a like path here, means like for this 10.2, so the Palo Alto firewall should take the return path in the same direction, not routing via this way, right? And policy wise you understand, like we can be more restrictive. Now Palo Alto firewall has only one route, and this route pointing where? To this interface, Ethernet 1/2 via Internet Gateway. But the default route means now this Palo Alto firewall should have route for 10.1.0.0, also for 10.2.0.0, and exit interface Ethernet 1/1. Right? So once like packet reaches Palo Alto firewall, sourcing with 10.1. and destined to 10.2 and then any IP address cleared with the security policy, Palo Alto firewall will perform routing table lookup, and Palo Alto firewall will find a route for 10.1 or even 10.2 and exit interface Ethernet 1/1. So what will happen now? Packet is now sent to the private subnet routing table, right? Not to transit gateway even. Private subnet routing. Now this private subnet routing table, right, we've just seen has only two routes, 172.16.2.0 and 0.0.0. Means now this private subnet routing table should have route to 10.1 and 10.2 and using this attachment, this direction, right, for return traffic. So private subnet routing table should have route back to both VPCs. So this way packet will get routed to transit gateway. Now transit gateway will check the routing table, do, and which routing table? The external firewall. That do I have route for 10.1 or 10.2, and yes, then what should be my attachment? How I should make that routing happen? So let's go step by step. So first, like Palo Alto firewall side routing. So we have successfully configured VPC1 routing table, transit gateway routing table, private subnet. We didn't do anything, not required, at least for this direction. Packet now successfully reached to Palo Alto firewall. I'm going to configure routing on Palo Alto firewall. Then I'll be back to this private subnet routing table, transit gateway routing table for return traffic, step by step. So Palo Alto firewall routing, you know like how to create a static route. So go to virtual router, default, and here static routes. There is already one gateway address, so I don't want to do anything for that. And this is my VPC1 route for VPC1, and this is route. Oops. And VPC1 is 10.1.0.0/16, and just specify the exit interface Ethernet 1/1. Next hop not necessary, so you can select none even, will work fine. Okay, and one more route here for VPC2 network. So VPC2 route here, and VPC2 is 10.2.0.0/16, and interface Ethernet 1/1 internal interface, right? So routing and Palo Alto firewall done, configured here, right? Let me go to private subnet routing table first. Private subnet routing table. So private subnet routing table has only two routes. So I'm going to create route for 10.1.0.0/16 via transit gateway. Return path, right? Transit gateway, and one more route 10.2.0.0/16 via transit gateway. Done. So we have configured routing on private subnet also. Let me quickly show you the routing table of transit gateway routing table. So where is transit gateway routing table? So now private subnet will send packet to which routing table? The third one, VPC has transit gateway has three routing table: VPC1, VPC2, and firewall subnet. So this private subnet will send packet to this transit gateway using this attachment, means like will uh, hit like this routing table, firewall VPC routing table. So what's the route there in firewall VPC routing table? Association is there. Remember we did that. What about routes? No routes here. Create a static route. So there are two subnet /16 and the attachment VPC1 10.1.1 reachable via VPC1 to transit gateway, and one more route here, and this time 10.2.0.0/16. So in order to reach 10.2.0/16, attachment 2 done. And now I'm going to quickly spin up two EC2 instances, one EC2 in VPC1, another one in VPC2. So this is my Windows machine or EC2 or virtual machine in VPC1 EC2, right? And I'm going to take Windows machine, Windows, and the key pair. I'm just going to create a new key pair because I don't remember the old one. So pim file, because for Windows like we need this pim file. My key pair. Save that, and the network configuration. So in which VPC? VPC 01. Perfect. There's only one subnet, auto sign public IP. Yes, we don't want public IP address. Security group. So is there any security group already created here? Permit all, no. So I want to create a security group, permit any, because we want to control traffic with Palo Alto firewall. So remove this rule, and the rule we want all traffic from anywhere. All right, launch. So EC2 is spinning up Windows based EC2, and I'm going to spin up another EC2, and this time in VPC2. VPC2 and then EC2. Okay, and this time I'm going to spin up Linux machine, no problem. One Windows, one Linux machine, G2 micro, key pair, select that. So I selected key pair and the edit network. This time VPC2, VPC2 public IP, no, not required. Then again here permit all or any, permit any, same. I'm going to put it here. Security group, so all traffic. All right, so we're good to go now. VPC2, okay, launch. So view all instances, right? So I hope you understand routing well, that what we did in this transit gateway routing table, because this transit gateway routing table there are three routing tables. So transit gateway routing table. So you need to focus here. One routing table is for VPC1, another routing table for VPC2, and the third routing table for this firewall VPC, right? So in firewall VPC, last we configured routing this way: 10.1.0.0, 10.2.0.0. So for this 10.1.0, we selected target VPC1 dash TG is the attachment, and in order to route packet to 10.2, we selected target as VPC2 TG. Correct? Good. So this one, right, in firewall VPC. And what about other two? VPC1 routing table here, in fact, and then VPC2 routing table. So we just put the default route. I mean, like traffic coming from here or here. So since we are not configuring routing this way, no, like local routing, I mean, like not routing directly via the transit gateway. That is why we created a default route here, because all the way, like the next stop should be your Palo Alto firewall, right? So the target should be, attachment should be firewall. So what we did, we created default route in VPC1 and VPC2 routing table. Transit gateway attachment association is also very important, right? So what we did, we attached VPC1 TG with this routing table, VPC2 with different routing table, and the third one. So that's the way, like how we configured routing. Now let's hope like this topology work. We in without troubleshooting. I mean, like we did so many things here. So we can check like pinging this machine from here. Not exactly, we don't know like the IP address actual. In fact, because uh, I could have assigned a static IP address to the EC2, but I forget that. But no worries, automatically private IP address will be assigned from the same subnet and here and here. So we can check like this way. I mean, like we can ping this computer Linux machine from this Windows computer. This way ping will not work because on Windows by default firewall is enabled. We can also check the internet connectivity. But the big question, this EC2 is in private subnet, no internet connectivity. I'm sitting here is my laptop. How I can access this EC2 instance? And the best verification even this way, right? RDP from outside. So for that, this Palo Alto firewall should have destination NAT policy configured. Because what I did, I didn't assign any public IP address to this EC2, not even to this EC2, no internet connectivity at all. Because that's the best way to verify like the whole configuration. Because if we are able to take RDP of this Windows machine through Palo Alto firewall, and we can check that with the log, so very much like configuration is working, and then we can initiate traffic outbound also this way, and also to another VPC, right? So let me quickly create destination NAT policy. Security policy, we are not worried with the security policy because security policy has what? Permit any statement. Security policy has permit any statement is timed out, so I'll have to log in again. So security policy wise, like no problem. Security policy means permit any source, any destination, any service, any application, any allow in all the way. I mean, like in both the direction, inside to outside, outside to inside. But in NAT policy, there is only one NAT policy, source NAT, and now I'm going to create a destination NAT policy. And before that, let me quickly check the IP address of this Windows machine in VPC1. So private IP address is 10.1.1.34, and even this Palo Alto firewall should have public IP address assigned because external interface has only private IP address, right? Which IP? 172.16.3.10. If you remember, management interface has like one private and public, but external interface only private IP address. So in order to configure destination NAT, a public IP address need to be binded or associated or attached with firewall external interface IP. So what I'm going to do before creating destination NAT policy, I'm going to allocate elastic IP address from here and then attach or associate elastic IP address with Palo Alto external interface, external, this one, private IP 3.10, perfect. And this is the public IP address. So I will be accessing Windows machine with this public IP address, RDP I mean. And the private IP, you know now, private IP is 10.1.1.34. Alright, so I'm back to this. Don't show this again, close, no problem. So I'm going to create destination NAT for RDP. So this is my destination NAT for RDP. RDP. Okay, so source zone outside, destination zone also outside. You know the reason, because both IPs are resting in the outside zone. Source address any destination address, firewall external interface IP, but here we take private IP, that is 3.10, and one NAT is automatically done on the internet gateway side. So here select the static IP, and the Windows machine IP is 10.1.1.34. 34, and even we can specify service here, even service any will work for me, no problem. And even I can create a service here, TCP port, we know, like 3389. Okay, routing is done. Commit the changes. Miscellaneous session, there's too many routing and other configuration, and even firewall VPC and firewall is spinning up already, we have already completed in previous session. So once it's done, then I will take RDP. I will try to take RDP, right, from my laptop, from here with the public IP. And even if I am able to take RDP of this EC2, means the entire configuration up to the mark, right? The whole routing, because I'll have to reach here a lot of devices in the middle of communication stream. And then we can also test outbound traffic, internet bound traffic, even traffic destined to VPC2, but not like taking a U-turn from here only. No, not this way. Not this way, right? Via Palo Alto firewall. So config is done. I'm going to take RDP now. Alright, so 65.0.194.113 is the public IP address of Palo Alto firewall external interface. Alright, so something wrong with the configuration. Remote desktop cannot connect to the remote computer. So let me quickly go to Palo Alto firewall side and monitor. So first I want to see like whether traffic hitting Palo Alto firewall or not, and is my IP address right? I can see here, and port 3389. So let me open this log. So at least type is end, in fact packet hitting Palo Alto firewall and the source IP, source country, destination IP, destination port, NAT IP with the policy yes allowed, application incomplete, three-way handshake didn't happen. So after first packet like reset, why it is so? Destination 3.10. Oops, here is the problem. So problem I can see the NAT IP is 10.1.1.3, but our Windows machine IP is 10.1.1.3, right? 3 is wrong. So I think we have done some typing mistake in NAT policy, but let me quickly verify the IP. IP is 34, not 3, right? But with NAT policy, it's getting translated to 10.1.1.3. So it's about the NAT policy configuration, I believe, nothing to do with the routing and other configuration that we did, 10.1.1.3. So let me quickly go to NAT policy and verify the policy that we have just created. The destination NAT policy is everything up to the mark? Probably not. Yes, here is the problem. Typing 10.1.1.3 and IP here 10.1.1.34. So 4 just because of my keyboard, I think. Alright, so 34 commit changes, then again we'll try to take RDP of EC2 in VPC1, right? And once we have reached successfully here, then from here we can initiate outbound traffic, internet traffic, and also to EC2 machine, the final configuration. So let this be almost done. 98%. After 99%, we can try. Yes. Minimize. We are on the same page. Connect. And see what happens now. Remote desktop cannot connect to the remote computer for one of the following reasons. So still there seem to be some issue with probably Palo Alto firewall. So policy is correct now. So 1R34. And what about routing? Default static route we created for these two, VPC1 and VPC2, Ethernet 1/1. So this looks good. Ethernet 1/1 is this interface, Ethernet 1/1. Okay, but there seem to be some routing issues. So sometimes what happens in cloud, this next hop none doesn't work properly, right? So probably this routing is causing the problem because NAT policy is up to the mark now, security policy, no restriction, and VPC transit gateway routing table all are properly configured, so we don't have to check anything there. So what I'm going to do, I'm going to change next to, right? So obviously exit interface is Ethernet 1/1 and the next hop is this routing table, like this AWS managed routing table is in private subnet. So the first IP address is the gateway address. So what I'm going to do, I'm going to configure next hop IP, right? So I'm going to change this next hop over the IP address and 172.16.2.1 first IP address is gateway IP address, and same for this also. Next hop IP and the IP internal like private subnet routing table 172.16.2.1, right? So I changed routing and I think timed out. probably refresh. So config not saved here. So next up IP address, and IP address 172.16.2.1. Okay, private or internal network gateway IP address. And same I'm going to configure for 10.2. So instead of next hop none IP address, because in cloud sometime this creates problem. So because definitely it's a routing issue. So hopefully this time the configuration should work. So what we did first, like we change IP address in the NAT policy, and now this routing, right? Once it's done, then we will initiate RDP connection to EC2 machine. We'll also check or verify outbound connectivity, and then we can ping EC2 machine in VPC2. Or also we can use network analyzer tool, a very good tool in AWS in fact. So 99% done. Minimize this. And again, I'm going to initiate RDP. Yes, done. All right, so now log in, and we need to take password for this EC2, VPC1 EC2, RDP client, get password. Decrypt, and here is the password. All right, okay, yes. So very much like we are inside this EC2 Windows machine, right, through Palo Alto firewall. Windows computer doesn't have public IP address, no gateway attached with the VPC. The single exit point is Palo Alto firewall VPC, right? So the only way to route traffic outside VPC is via Palo Alto firewall. Even in different VPC, like towards internet, in fact. So it's like getting looted. In the meantime, just to save time, quickly I want to show you another tool so that can be handy in troubleshooting, especially if there is some issue with the ACL, or maybe that's your security group. So tool is reachability analyzer tool. So create and analyze path. So name it path 01, and the source type instances, and which one, EC2 in VPC1, destination again another instance in VPC2. So what I'm trying to do, I'm trying to initiate traffic from one instance to another instance, and both instances and two different VPCs, right? And what we want to verify, the path, which path is taking, right? So we would like to see a multi hops in fact, because this trace is very good tool in fact. And so we are doing a trace like from like VPC1 EC2 to VPC2 EC2. So output will display like first hitting ENI of the same EC2, and then security group, then network access list, then transit gateway, then firewall ENI interface, then again taking another path. So it's very, and in case if any issue, then will output will like mark that point like what is the issue. Even if you want to test out like the port also, so you can specify port, protocol number. A very good tool. It just take a minute or so. So request to run and analysis succeeded and is running. So we'll be back to this screen, right? Once status is there, either like successful or not successful, right? We are expecting successful, obviously. And yeah, it's working 10.1.1.34. Can we also test internet connectivity from here? We can see that log on Palo Alto firewall. Yes. So I'm going to access a website, any website. So wait here, it's taking time. So start without any data, continue without this data. So at least now we have Microsoft Edge in Windows 2022 server. It's good. So here I'm going to access facebook.com and it's running on 1 gig of RAM, so you understand like the performance. So in free tier resource is very limited, just 1 gig of RAM, so that is why it's taking very long time. And see here like Facebook at least load it up, and also we can try accessing some more site here. It's working. Twitter.com. Type here. Let me delete this. So it's very slow. Twitter. So it's very slow because we spinned up Windows 2022 server with 1 gig of RAM. So you understand the reason. But anyway, it's working fine. Like there is proper internet reachability here, and we can also test IP reachability in different VPC. I mean, like we can ping Linux machine. So if I can open CMD from here, and Google is working, yes, like it's more than enough, like just verification. So we need some data in Palo Alto firewall so that we can verify traffic log that yes, internet outbound traffic is passing through Palo Alto firewall, right? So it's very slow. And what's the IP address of Linux machine? I don't know. So need to go to VPC EC2 and 10.2.1.26. So 10.2.1.26, right? And on Linux machine, ping is by default allowed. And you can see the success here, right? And packet is passing through, returning from, rather, I would say, Palo Alto firewall. And we can verify same from here also. Just refresh the page, and yes, it's successful, right? Reachable. And now I'm going to show you the output here. First here, VPC1 EC2 started from here. So first one VPC EC2, and then ENI of the same machine, EC2 in VPC 1, and then security group attached with the same EC2 permit any, and then ACL, right, associated with subnet, and then routing table, VPC routing table. See here, VPC1 routing table, and then after that again ACL, probably yes, ACL, then ENI, and you can match with the ENI ID also in case if there is any confusion. So is ENI, you can check this, and then transit gateway. So hit the transit gateway, and then transit gateway routing table. You can see here transit gateway routing table, and check the routing table, VPC1 transit gateway, because attachment associated with it, and then transit gateway RT VPC1, then firewall VPC TG, right, went towards Palo Alto firewall, and then here private routing table. Look at this, Palo Alto firewall, and then again like returning packet from there. Now you understand, right? So it's another way of doing verification. Here you see it's reachable, then it means everything is up to the mark. So I hope you understand how we can configure routing to ensure that all traffic or traffic from different VPCs are like first inspected with the Palo Alto firewall, and then in case of internet bound traffic taking like internet route, and in case of different VPC again returning packet to the transit gateway, and via transit gateway like different VPCs can be reached. So mainly it was about the routing concept, moreover like is something routing, transit gateway attachment, and routing table, right? But very good design, because this way like even if you have one VPC in region 1, another VPC in different region, third VPC in third region, and you don't want to spin up a large firewall in each VPC, or maybe you want a single exit point, maybe for like logging, monitoring, for other purposes, and of course you definitely will save money, right? So it's the best design in fact, like configuring routing this way. All right, so that's all about this single exit VPC for other VPCs in fact, right? Okay.